Again, the formula for average value, not the average rate of change, not the rate of change, but the average value of a function on a given interval, 1 to 4, 10 to 13, is
it 1 and then b minus a and then times integral of the function?
from a to b, from f of x dx. So this is f average on the given interval a comma b. Awesome, thank you. A differential equation is an equation that has in it
A function?
yes, but it has to have, if it only has the function, that's not a differential equation. This is a differential equation. What has to have in it? It has the function, of course, but what has to have in it?
Y prime?
Exactly, derivatives. Derivatives, otherwise it's not called a differential equation. It's called a differential equation because it has derivatives. One or more derivative or derivatives in it. With the function, without the function, we don't care. But if it does not have at least one derivative in it, it's not a differential equation. Awesome. We solve for the, when solving a differential equation. What are we solving for? We're not solving for the derivative, of course. We're solving for the whose derivative is given in the differential equation.
The solution?
The function.
Okay.
So the solution is the function. So we solve for the solution, which is the function when solving a differential equation. The function whose derivatives exist in the differential equation. Awesome. One type of a differential equation is called
Separable?
very good. We need to, let me see what I did here. Okay, so let me think what I wanted. So
Does it separate the function?
very good, yes, thank you. We need to separate the,
Function?
no, we separate the
Variables?
the two variables, right? And then what do we do to both sides after we separate the variables? We
Integrate?
then integrate. Excellent. Awesome. Finally, number 4, the condition given to help us determine a unique, just one solution. So a unique function is called the condition. Has a specific initial. Very good. This says it very important. It's specific. It's called an initial condition. For example, and we may be given f of 0 equals 2. This is the initial condition. Or it may be given like this: x equals 0 when y is 2. Okay, awesome. Initial condition. Well done, well done, well done. Thank you, thank you. So now I'm ready for your questions. That's page 2. Anything you'd like to start with? Anything? Anything you need help with, MyLab Math or written homework, anything you want?
Can we do them?
Yes, I'll write them down and we'll do them in any order you like.
I was gonna say 48 on the written homework.
48 on written homework. I'm assuming
That's
this
what I was
is
gonna say too.
5.7, right? Good. Anything else?
There's also a MyMathLab one. On 5.7, number 10.
Good. Anything else? Okay, so let's start with 48. 5.7, 48. Let's see. I'm just looking for the page number so I can put it. I have the book up. Page 48 is on page 536. I'm going to share my screen. I was ready to start 6.1, 536. I hope I'm not logged out. Okay, so, okay, perfect. So the reaction R, so this is dr, which is a function of S, right? In pleasure units by a consumer receiving S units of a product can be modeled by the differential equation. So R is in units, S is in units. So that's my first thing. First thought, dr over ds equals k over s plus 1. Perfect. So I take notes. R and S in units. Fine. So we are given the differential equation. And they're asked us, use separation of variables to solve the differential equation. Of course, we are solving for the function, which is R. Good. So any suggestions? What would be the first step?
I would say first multiply by ds to get rid of a ds on the left side.
Excellent. So dr equals k over s plus 1 ds. Perfect. R is alone on one side. K is a constant. Let's see what they say about K. Are they saying anything about K? K is a positive constant. That's it. We don't have to worry about it. Don't even look at it. So R is alone on one side. There is no R here. S is alone on one side, and there is no S here. So it's already separated. What will be our next step that we just reviewed a second ago?
Integral.
Good. We are integrating both sides. So don't look at the right-hand side. We're integrating the left-hand side. Which function prime is 1? Now keep in mind we have dr.
R.
That's it. Good. Now forget about the left-hand side. Let's look at the right-hand side. K is outside. So we have the integral from ds over s plus 1. How do I integrate this? What will be our first step? Here's your hint.
S plus 1
Good. What about du?
is 1.
Du cannot be 1.
DS.
Yes, 1 times ds. Perfect. So then we have r equals k, the integral from du over u. So this is k, which function prime is 1 over u. And please do not forget the absolute value. This is crucial. We need the absolute value.
ln of u.
Absolute value of u plus a constant c. So we have that r equals k, natural log absolute value of u, plus a constant c. Okay, so now let's see what they want. We solved the differential equation. We have r. If you want, and we have to go back. Sorry, it's a must. So we have to go back. This is natural log of the absolute value of s plus 1 plus c. Good. So now let's go back to so use separation of variables to solve the differential equation. Done. That's part A. In part B, rewrite the solution in terms of the initial condition, r of 0 is 0. Does it make sense? Yes, it makes sense, right? So if I'm not buying anything, I guess I don't feel any pleasure because I didn't buy anything. Well, I can feel pleasure in other things, so watching something, running. But in the context of the problem, does r of 0 make sense? Yes, it does. So we are given the initial condition that r of 0 is 0. So when s is 0, how much is natural log 1?
0.
0. How much is 0 times k?
0.
Perfect. And this is 0. So 0 equals c. So this is 0. So the final answer for us is r of s, if you'd like, to show that it's a function of s, equals k, whatever the constant is, natural log the absolute value of s plus 1. You can say s cannot be -1. S cannot be 0, so it has to be 0 or more, right? So I could change this into parentheses. That's all we needed to do. Anything else? Is it clear? Are these steps okay? Everyone? Okay, so now let's look at 5.7 number 10. So can you share and show this to us, or do you want me to go to that?
I can just share it.
Okay, so I gave you permission. You have permission to share. That would be great. Okay, so a firm's marginal profit, which means P prime, as a function of its total cost. Okay, so we have P of C, okay, is given by the equation below. Okay, so dP over dC equals negative 210 divided by C plus 1 to 3/2. Find the profit function P of C if P is $10 when C is 35. So the point is 35 comma 10. C is the independent variable, 35, and P is the dependent variable, 10. So I have the point when C is 35, P is 10. And then we'll come back to part B. At what cost will the firm break even? Okay, so then part B, I'm just going to write it so you don't have to share. So in part B, they're asking us the cost, which is C, the independent variable. What is the independent variable when the profit is 0? That's good enough. That's fine. We have all the information. Perfect. Thank you. Good. So we have dP over dC equals negative 210 over C plus 1 to 3/2. So disregard this for a moment because that's part B. So now let's see, part A. So what do we do here?
Multiply by DC.
Very good. So we multiply everything by DC. So we get dP equals negative 210 over C plus 1 to 3/2. And this is times DC. P alone on one side, C alone on the other. There is nothing else in there but numbers and C. What do we do next?
Integral.
Good. So we integrate both sides. The left-hand side first. What do we have here?
P.
That's it. Awesome. Now the right-hand side. I will move the negative 210 outside because it's a constant. So then I have dC over C plus 1 to 3/2. So here's your hint. Let U be.
Would it be C plus 1?
That's it. We need du, without which we cannot continue. If we don't determine du, we cannot change the integral.
DC.
That's it. When we differentiate this, we get 1, but we have to multiply by dC because this is the differential, not the derivative. Awesome. So then P equals negative 210, the integral from, this is du, but this is 1 over U to 3/2. U to negative 3/2 du. And this we know is negative 210. And what do I write? So U to negative 3/2 plus 1, which is negative 1/2 over negative 1/2. We continue. I flip this, multiply negative with negative, which will be a positive. So when I multiply 210 by 2, I get 420. And this is 1 over the square root of U, which is C plus 1. I don't like this. I'm going to write D here. Sorry. Plus a constant D. Not to be confused with this with the cost. Okay. Good. So this is the solution. So this is P of C. But now they're telling us 35 comma 10. Why is this given to us? When C is 10, when C is 35, P is 10. Why is this information given to us? What for?
To find D.
To find the constant. Awesome. In other words, to find the unique function. Awesome. Yes. So let's do that and find D. Good. So that's my page 4. Let's see how we are with time here. Oh, okay, we can finish that. Perfect. So 10 equals 420. The square root of 35 plus 1 is 36. The square root of 36 is 6 plus d. So 10 on the other side. I'll simplify by 6 and I get 70. When I subtract, I get c equals negative 60. Ah. So the constant is negative 60. So now I can write the function, finally. P of c equals 420 over the square root of c plus 1 minus 60. And this is part A. In part B, they want us to find c such that the profit is 0. So this is part B. Before we move on to part B, any questions on part A?
Yeah, the answer for part A, it says minus 32. Instead of minus 60.
Is it for part A?
Yeah,
Did you write the function as 420 over the square root of c plus 1 minus 60?
yes, and it showed that it was 480 over the square root of c.
It says 480 or 420?
I mean, I could be wrong, but it.
They changed the problem when you went back in, and you're not getting the same problem with everybody else.
Okay, that could be it.
You have a different function.
Okay.
You don't have, look at the function that you have. You cannot have negative 210 over c plus 1 to 3 halves. You do have a different function. Can you read your function?
Yes. Nope, it's a different function. My
Yes.
apologies.
No, that's okay. That's absolutely fine. So not every student gets the same thing. So now, for example, when you put in an answer and you go back in, it will also give you another problem. If you make a mistake once or maybe twice, it gives you another problem. If I go in as myself, it will give me another problem. So if you don't have negative 210 over c plus 1 to 3 halves and the 0.3510, of course, everything you enter has to depend on the function you have.
Okay.
Better?
Yes.
Yeah,
thank you.
yeah, I forgot probably to say that. So we all get different questions, okay. So P of C was 420 over the square root of c plus 1 minus 60. So now we're asked to determine the cost for this to be 0, for the break-even point. So how do we do that?